All right, so let's start talking through these problems. Question number 1, as a group, we did pretty good on. The majority of people got this one correct. If you are wanting to compare the proportions of those surveyed within the 4 regions, then a segmented bar chart is your choice. That would allow you to do a bar chart for north and have yes and no, then a bar chart for east, have yes and no, bar chart for south, and a bar chart for west. So you'd have something like this, and it would allow you to look at them side by side. Does that make sense? Obviously, you would need to calculate percentages. I'm just throwing bars up there with shading. But you would need to calculate the percent of north that is yes and no, the percent of east that is yes and no. That's what it's talking about when we're comparing proportions. Segmented bar charts are always done with proportions, not with counts, because it's a way that I can compare groups of different sizes. Question 2, this is another one that most people got correct. In fact, more of us got this one correct than number 1. Based on the histogram, which of the following is the best description of the distribution? Option A says it's uniform. That means that all the bars should be reaching at about the same height. This is not uniform. Then we have skewed left and skewed right. It's not really skewed. What I'm noticing is that there's 2 clusters of data. So it's not A, B, or C. And then we have 2 clusters with a range of at most 200 seconds and includes outliers below 75 seconds and above 325 seconds. Well, if you look at the bar chart, there's no data that's below 75 or above 325. So it's not option D. This would be E. So far, so good? All right, let's look at number 3. Number 3, almost everybody got this one wrong. So let's talk about how to calculate number 3. It says events D and E are independent with the probability of D equal to 0.6 and the probability of D and E equal to 0.18. Which of the following is true? And then they have the probability of event E and the probability of event D or E. So it tells me that they are independent, which means that the probability of D and E would be equal to the probability of D times the probability of E. This will always be true for independent events. This is one of those things that I need you guys to just know. This will not be on the formula sheet. You need to know that for the and, for independent events, for the intersection, you multiply the individual probabilities together. We have that the probability of D and E is 0.18. The probability of event D is 0.6. And that's getting multiplied by the probability of event E. So then I would divide both sides by 0.6. And you end up getting 0.3 for the probability of event E. So that's enough right there to toss out choices A and B. So now we're going to have to go and look for an OR, a union. This is where your reference page can come in handy. The reference page, if you did not find that yesterday, the reference page is right here where it says chi-square and then reference. If you click on that, it will pull this window up. You can navigate to statistics or you can go to the tables. We want statistics. We're specifically looking at probabilities and distributions. So I'm going to click on this here. This is the rule that I want to use. The probability of the union, the OR, is equal to the probability of A plus the probability of B minus the probability of the intersection. I now have all 3 of these pieces right here. So we're going to be able to calculate the probability of the intersection. So probability of D or E is equal to the probability of D plus the probability of E minus the probability of D and E. So 0.6 plus 0.3 minus 0.18, and we end up getting 0.72. So you have to know the independence rule. The general addition rule is given to you on the formula sheet. I definitely want to encourage you guys to make use of the formula sheet. However, you can't go and check to see if there's a formula for every single problem. You need to know like which problems you should be going and checking the reference page for, because you only have 90 minutes to do the multiple choice, which is a little bit more than 2 minutes per, but if you spend a lot of time poring over the formula sheet, you're going to waste some of that precious time. Number 4, researchers used 2 footballs of the same size to examine the effect of helium on kicking distance. One football is filled with air, the other was filled with helium. 11 people participated in the study. Each person kicked the football filled with air and the football filled with helium. So each person is doing both things. By the way, on number 4, we had a majority of people miss this problem, but not as bad as question 3. So each person is going to do both of these pieces. That's the, like, before I even get down to the answer choices at the bottom, that sounds like a matched pairs setup. You have one person with 2 conditions. That is a perfect setup for matched pairs. The football that was kicked first was determined by the flip of a fair coin, and the people did not know which football was filled with air and which was filled with helium. What type of study was conducted by the researchers? And, of the following, which is the appropriate T interval for inference? This is not completely randomized. Completely randomized would be where you take all the participants, split them into 2 groups. One group kicks the helium, the other group kicks the air-filled balls. Here we have one person doing both. So like I mentioned, this is a perfect matched pairs design. It's not an observational study because the participants are being told what to do. It's not like they just got set loose on the field and said, go kick a ball, and then they recorded which ball they picked. So matched pairs design and a T interval for a difference between means for independent samples, or a T interval for a mean difference. This right here. Independent samples. Do we have 2 independent groups, one kicking helium, one kicking air? No. The other thing that I'm looking at is the language before that, the difference between means. This means subtract 2 different mu's. So this would be a mu1 minus mu2. The mean difference is the average of the differences. So mu diff. That's what we do for matched pairs. We want the mean, the average, after you've subtracted all of these. Helium minus air, helium minus air, helium minus air. You take all of those numbers and then calculate an average. All right, number 5. Number 5, we are back to not very good on this one. A survey of a random sample of 1,045 young adults found that 60% do not have a landline telephone number. This was found from a study, right? So that is a p-hat. A hypothesis test will be used to determine whether the data provide convincing statistical evidence of more than 50% of all young adults do not have a landline telephone number. So what they're telling us right there is that the null hypothesis is that mu equals 0.50, and the alternative hypothesis is mu is greater than 0.50. So we have some evidence for ha, because 0.60 is bigger than 0.50. So far, so good? All right. Which of the following is the test statistic for the appropriate test? So this is z equals p hat minus p over, and then big square root. I'm going to go back and look at the reference page because this bottom, this denominator, is something on that reference sheet. All right, so we're going to close probabilities. Sampling distributions and inferential statistics. Anytime they're talking about confidence intervals or hypothesis tests, That is inferential statistics. So hypothesis test confidence intervals, I'm coming here. So I'm going to click on this. Right here it says sampling distributions for proportions. Here's how I calculate the standard deviation for proportions. P times 1 minus P over N, all underneath the square root. P times 1 minus P over N. When it comes to formulas for standard deviation, especially if it's for two populations, please go use that reference page. I don't want you guys to miss the problem because you used the wrong formula and you had access to the right formula. We use P here and not P hat because the null hypothesis is saying this is P. So that would be 0.60 minus 0.50. Just with that much right there, I can get rid of which choices? A and B. That has parameter minus statistic. We want statistic minus parameter. Over the square root of 0.50 times 1 minus 0.50 over 1045. What's wrong with E? They only square rooted the denominator. That's something that we do when we're doing inference for means. That's S over square root of N, but that's not for proportions. So this would be choice C. Choice D is almost exactly the same, except they used P hat instead of P. We use P hat to do the standard deviation when we're doing intervals, because we have no idea at all what P could possibly be. When it's a hypothesis test, you are starting with the understanding that we say the true proportion is this, and then we go looking for evidence that it's not. But we have to start from that foundation, so we have to say this is what P is. Before we go look at number 6, does anybody have any questions for me? All right, if I go too fast, please let me know. I don't want to go too slow or too fast. Too slow, you guys get bored. Too fast, it's not any good. Number 6, we were about 50-50 split on this one. Based on the box plot, which of the following statements must be true? And this box plot is showing me an airline that recorded the number of on-time arrivals for a sample of 100 flights each day. The box plot summarizes the recorded data for 1 year. Part A says the range of the number of on-time arrivals is greater than 90. Well, range is max minus min. It looks like their scale is 2, so like that would be 82, 84, 86, 88, 90. So the maximum is up at 94, and the minimum is 72. Well, if I subtract those, I definitely get a number that's smaller than 90. So this is not option A. The interquartile range of the number of on-time arrivals is 22. IQR is Q3 minus Q1. That's the same thing as the width of the box. So from right here to right here. That is not 22. That is 4. So it's not option B. The number of days that had at least 80 on-time arrivals is greater than the number of days that had at most 76 on-time arrivals. So they're looking here and here. I know those are the boundaries for Q1 and Q3, but I have no idea how many values fell on each one of those exactly. I know that the box is 50% of all the days in 1 year. So that'd be 6 months, half a year. I know that this much right here is 25%, and this much here is 25%. But I can't tell from a box plot how many on-time arrivals or how many days with 80 on-time arrivals there were versus how many days there were with 76 on-time arrivals. I just don't know. So it's not that one. The number of days that had 76 to 80 on-time arrivals, that's 50%, is equal to the number of days that had at most 76 on-time arrivals. At most 76 on-time arrivals, that's 25%. So one is 3 months, one is 6 months. That's not the same number of days. So process of elimination says this has got to be E. The difference between the median and the lower quartile for the number of on-time arrivals is less than 2. Well, here's my median. And here's the lower quartile, Q1. If I look at that distance on the number line, that is less than 2. It looks like it's 1 based on the box plot. So this is option E. Number 7, we were about 50-50 on this one also. There it is. A tropical storm is classified as major if it has sustained winds greater than 110 miles per hour. Based on data from the past 2 decades, a meteorologist estimated the following percentages about future storms. 20% of all tropical storms will originate in the Atlantic Ocean, of which 20% will be classified as major. So the probability that it's happening in the Atlantic is 0.20. Of which 20% will be classified as major. So it's going to be a major storm, given that it is occurring in the Atlantic, 20% of the time. And then next one down, 30% of all tropical storms will originate in the Eastern Pacific Ocean. So the probability of Eastern Pacific is 0.30. Of which 15% will be classified as major. So the probability that the storm is major, given that it originated in the Eastern Pacific, is 0.15. And then finally, 50% of all tropical storms happen in the Western Pacific. So the probability of Western Pacific is 0.50. Of which 25% will go on to be major storms. So the probability that it is a major storm, given that it happened in the Western Pacific, is 0.25. Based on the meteorologist estimates, approximately what is the probability that a future tropical storm will originate in the Pacific Ocean and be classified as major? So I want the probability that it is Eastern Pacific and a major storm, together with the probability that it originates in the Western Pacific and is a major storm. I can just add these two together without worrying about subtracting anything back out again, because these are mutually exclusive. If the storm originates in the Eastern Pacific, it can't originate in the Western Pacific. If it originates in the Western Pacific, it can't at the same time originate in the Eastern Pacific. So these are mutually exclusive events. I can add those two probabilities together. We actually have a formula on the reference page that would be useful here. We're looking at probabilities and distributions. This is that second rule. The probability of A given B is equal to the probability of A and B over the probability of B. That's what I'm going to use here. So the probability of A and B, or sorry, A given B is equal to the probability of A and B over the probability of B. This is what we're wanting for both Eastern Pacific and Western Pacific. So for this one right here, I have the given that as 0.15 is equal to, I don't know what's up here, but I know the denominator is 0.3. So then I would multiply both sides by 0.3. And so the probability of Eastern Pacific and a major storm would be, I think that's 0.045. Yes, 0.045. Plus, now we're going to do the same thing for Western Pacific. I have 0.25 is equal to the thing that I'm looking for over 0.5. So I'd multiply both sides by 0.5. And for this one, I get 0.125. When you add those two together, you get 0.17. So option C. You can absolutely do this one with a tree diagram as well. That's the way I kind of talked through this in 5th period, was using a tree diagram. Is anybody interested in seeing how I would do this with a tree diagram? All right. I will post the slide with the tree diagram on it that I used in 5th period if you're interested in seeing that. So that'll be up on Canvas. Question number 8. Research indicates that the standard deviation of typical human body temperature is 0.4 degrees Celsius. Which of the following represents the standard deviation of human body temperature in degrees Fahrenheit, where F is equal to 9/5 C plus 32? This is a linear transformation. We're talking about standard deviation here. Do we add and subtract standard deviations or with standard deviation? Never. So if I'm talking F equals 9/5 C plus 32, we get rid of this part. And so to convert the standard deviation into Fahrenheit, I have 9/5 times 0.4, which is option B. Question 8 was about a 50-50 split. Question 9, most people got this one correct. There's a couple different ways you could go about approaching this problem, but there's a word up here in number 9, 2 words actually, approximately normal, that makes me light up, because when I see approximately normal on a question like this, I'm going to be able to use my calculator. We have the mean, 122 pounds. We have the standard deviation. We have a lower boundary. We have an upper boundary. So normal CDF, 114, 138, 122, and 8. Lower bound, upper bound, mean, and standard deviation. You can do this one using the empirical rule. It is more involved. The calculator is going to be much faster on a question like this, but you can solve this problem using the empirical rule. We end up getting 82%. Number 10, measurement of water quality were taken from a river. Measurements of water quality were taken from a river downstream from an abandoned chemical dump site. Concentrations of a certain chemical were obtained from 9 measurements taken at the surface, 9 measurements taken at mid-depth, and 9 taken at the bottom of the water. What type of study was conducted, and what is the response variable of the study? Most of us got this one right. Is this an experiment? No. There's no treatment being imposed on the water. A census would mean that you have to talk to or get information from every single member of the population. Well, if the population is all the water, we can't go and get information from all the water. So a census does not make sense in this situation at all. So this is an observational study. And we want to determine what the response variable is. What is the thing that's being controlled by the researchers? The depth that they're going down to. So that is not the response variable. They have control over that piece. They choose that piece. The output that they get from that choice is the response variable. And what they are finding at these different depths is the concentration of the chemical. So this would be option D. All right. Number 11. Almost everybody missed this one. Ecologists wanted to estimate the mean biomass, amount of vegetation, of a certain forested region. The ecologists divided the region into plots measuring 1 square meter each, and they selected a random sample of 9 plots. Right here, they're telling me N. The mean biomass of the 9 plots was 4.3 kilometers per square meter. So that's mu. Is that the mean of means, or is that the mean of proportions? Are we talking about proportions on this one? No. So when I go look on the formula sheet, I'm going to go where it says, where it's talking about means. Standard deviation was 1.5 kilometers per square meter, so there's my sigma. Assuming all conditions for inference are met, which of the following is a 95% confidence interval for the population mean biomass in kilograms per meter squared? So this would be X bar plus or minus T star, has to be T because we're not talking about proportions. Proportions would be Z star times S over the square root of N. This is on your formula sheet. Put away probabilities, come down here. Sampling distributions for means, right here, sigma divided by the square root of N. This is what we're using for standard deviation right here. Or you could look at it as standard error because we don't know what sigma is, so we're doing this. Bar. The X bar, where did it go? 4.3. I lost it for a second. So I should label that, sorry, not as mu, but as X bar. Plus or minus, we're going to need T star. But then we have S, which is 1.5 over the square root of N, square root of 9. Before I even go and find T star, which ones can we throw out? We can get rid of C, because C has the square root up in the numerator. They're square rooting S. Which one did you say, Abby? We can get rid of A for the exact same reason. And I heard another one. D. Because of that denominator, they forgot to square root N here. All right, so now the only difference between B and E is whatever value we choose for T star. How many degrees of freedom do we have here? 8 degrees of freedom and minus 1. And we want it for 95% confidence. So we have to go back to the reference sheet now. Back up to the top. I'm going to switch over to tables. We want our T distribution. Remember, you can go to this table right here to find your Z star and your T star. Z star would be found all the way down here with infinite degrees of freedom. Infinite degrees of freedom is the same as our Z stars. We want 95% confidence with 8 degrees of freedom. So I'm going to scroll up. Wait, which one was it? Right here. Eight degrees of freedom. It's 2.306. So that means it is option E. Number 12. Most people got number 12 right. The question down at the bottom, I'm going to skip the top part for right now for time. It says, which of the following describes the sample and the population to which it would be most reasonable for the staff members to generalize the results? Well, it tells me right here that they randomly selected 50 conference attendees. So the sample is the 50 conference attendees. So it's either choice A or choice B. Can't be C, D, or E. Where did they go to collect their sample? They went to the conference. So who can they generalize their results to? The conference. They might be interested in the opinions of everybody in the state, but they did not get their sample from everybody in the state. They got their sample just from the conference. Number 13, we were about 50-50 on this one. More people got it right than wrong, but it was about 50-50. Based on the dot plots, which of the following is greater for the percent moisture of corn than for the percent moisture of soybeans? So I want corn greater than soybeans. And they want me to compare the first quartile, the median, the third quartile, the range, and the interquartile range. I'm going to start with the easiest one to calculate. Which one up there would be the easiest? I would think range. So range for corn, maximum is 20%, minimum is 7%, so that's 13%. Range for soybeans, maximum is 19%, minimum is 8%, so that would be 11%. Is corn bigger than soybeans? Then we found it. It's the range. There are 28 dots for corn and 28 dots for soybeans. So you could find the exact middle, the median, by crossing out dots from either end and find the middle. And then you can find Q1 and Q3 also by taking the smaller 14 dots and splitting that into 7 and 7. And then Q3 taking the larger 14 dots and splitting that into 7 and 7. So we could do that to calculate the first quartile, the median, the third quartile, and then we could use that also to calculate the interquartile range. But we don't need to do that because we found it on the first try. Question 14. 50-50 on this one. A sleep time of 15.9 hours per day for a newborn baby is at the 10th percentile of the distribution of sleep times for all newborn babies. Assuming the distribution is normal with a standard deviation of 0.5 hour, approximately what is the mean sleep time in hours per day for newborn babies? And we have what the sleep time is that is at the 10th percentile. So I need the z-score at the 10th percentile. You can use table A to do this, or you can do inverse norm. Since I want the z-score, the mean and standard deviation are 1 and 0. So I want 0.10, that's my area. Mean of 1, standard deviation of 0. Always true when finding z-scores. Yes. Yes. Thank you. 0 and 1. Thank you. You're right. If there was a standard deviation of 0, it would just be one big tall bar. All right. Has anybody popped this into a calculator? Negative 1.20. So we'll just go with negative 1.28. So we have z is equal to our value minus our mean over our standard deviation. So I have negative 1.28 equals our x value is 15.9. That came from the number that they said was at the 10th percentile, minus the mean divided by our standard deviation of 0.5. You get about 16.5. Number 15. See how we did on number 15. Most people got this one right. Number 15, most people got this one right. As part of a science experiment, the student recorded 10 measurements of the temperature of a liquid. One of the measurements was an outlier when compared with the other 9 measurements. Do they tell you anything about which way the outlier went? We don't know if it's much lower than the other 9 or much higher than the other 9. So could we say that the median for the 9 is less than the median for the 10? No. If it had a low outlier, we could say that, but we don't know it's a low outlier. Can we say that the median is greater? Again, if it was a high outlier, sure, but I don't know that it was a high outlier. I don't know about the maximums either, because again, I don't know where this outlier is falling. But the standard deviation, the variability, is going to be greater if there's an outlier than if there's not an outlier. I'm going to try to get through number 17 because that's where I stopped in the other class. 16. We were about half and half on this one. More people missed it than didn't. Important things on this question to pull out. It says that they found no association between age and preferred method of eating ice cream. That is another way of saying that they are independent variables. So that means the probability of event A times the probability of event B is equal to the probability of event A and B. So I'm going to pick one of the categories for age and one of the categories for how they like to eat their ice cream. I'm going to go ahead and just do adults and cone. So we should have the probability of adult times the probability that they prefer a cone. And that will give me the probability that they are an adult and they prefer a cone. Well, the probability of adult, that'd be 70 out of 210. Times the probability that they prefer a cone, that would be 150 out of 210. When you multiply those together, you get 0.238 for the probability of adult and cone. And so then I take that 0.238 times 210, because there were 210 people total surveyed. That will give me the number that is in the intersecting cell for adult and cone. We get 50. So if I'm looking at adult and cone, that would be here, 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 and here. The intersection, the and, should be 50. So it's choice C. All right. I've got just enough time to do number 17. We were about a 50-50 split on number 17. A two-sided t-test for a population mean is conducted of the null hypothesis, mu equals 100, if a 90% t-interval constructed from the same sample data contains the value of 100. If our null value is in the interval, would you reject or fail to reject? You would fail to reject. If you fail to reject, is p bigger or smaller than alpha? Bigger. So the p-value is greater than 0.10, and the null hypothesis should not be rejected. All right. That's where we're going to stop for today. That gets us almost halfway through these questions. I'm really hoping that we can finish up the multiple choice tomorrow. If not, there will only be a couple questions left that we need to go over on Monday. And then on Monday, we will begin grading together as a group the FRQ questions from your mock exam. You will be grading someone else's question, but then you will be handing it back to them so that they can see how they scored on that particular question. Those of you that have yet to take the mock, please try to have that completed by the end of the weekend so that you can get feedback on your answers.